Okay, so we'll start. Hello, everyone.
Yeah, sure.
Hello, everyone. Good morning and good afternoon, good evening, wherever you are. Uh, on behalf of Space Generation Advisory Council team in Yemen, I welcome you all in our second webinar, New Space and Opportunities for Non-Spacefaring Nations. Our speaker for today is Mr. Suhail As-Salahi. Just I will give a brief introduction about him. Mr. Suhail completed his master's degree in space and engineering systems from Russia. Currently, he is doing his PhD in space in systems engineering at Boston University, United States. Mr. Suhail worked as the SESC national point of contact for Yemen. He mentored various teams in different space activities. So he will be with us for 1 hour. 45 he will take for lecture session, and then we will have a question session in the end of this lecture. So anyone he can ask or he can write his question in the chat box. So on behalf of you, I welcome you, Suhail, and I request you to start your lecture.
Thank you very much, Ahmed. And thank you everyone for joining today. As you can see, the title of the lecture is, of the talk will be like New Space and Opportunities for Non-Spacefaring Nations. I chose this title specifically because I wanted to attract people who are coming from backgrounds who don't have opportunity and access to space. For example, we have people from the Middle East, from North Africa, from Eastern Asia, where we don't have space agencies or any space activities. And I was thinking, like, how can we bring these people so that we can actively contribute to the space sector and to the space activities? And also, this will bring a wave where also government will become interested in the space, in joining the space activities in the space sector. So I'll talk a little bit about myself. I'll start with that. I grew up in Yemen, where I finished my high school. Then I moved to Russia, where I did an undergrad in robotics and mechatronics. After finishing my undergrad, I started a master's degree in space and engineering systems. It was fascinating for me. I learned a lot of things at Skoltech. And during my stay at Skoltech, I did a couple of internships in Germany and in Yemen. The most relevant one maybe for our talk today is the one I did in Germany, where I worked on developing an antenna deployment system for a small CubeSat, like a 3-unit CubeSat. These are like very tiny CubeSats which you can send to the space. Don't worry if you don't know what a CubeSat is. We'll talk about it today as well. So I wrote my master thesis at MIT in the Systems Architecture Lab. And now I'm doing a PhD in systems engineering, where my work focuses on cyber-physical systems, network systems, and now there is an interesting project where I work on bio-cyber-physical systems. So in my free time, I like traveling. I do a lot of charity activities and organizational activities. For example, I was co-organizing the Space Up Skoltech 2018, if I'm not wrong, and I volunteered in organizing the Open Innovations at Skoltech. I also was mentoring teams at the MIT SciTech Ideathon. And this year, we are planning next week, the MIT Arab Conference. everyone is welcome to join. It's called the MITR conference, but there will be a lot of interesting things for everyone. This will be next week in the 13th. I will share the link with you at the end. And they also, I'm also participating, like quite active with the Space Generation Advisory Council. And so this lecture is sponsored by the Space Generation Advisory Council in Yemen. And hopefully this will be one of a series of lectures, depending on how how we find this and how the audience likes this talk. So I would like this to be interactive, like our session today to be interactive. So I would like to ask you to answer 2 questions for me here in the chat. If you can write where you are from and what do you do? Like, where do you study? Where do you study? Do you work? What do you study and what do you work? First, let's start with where you are from. Okay. I hope like everyone can find the chat down here. We have Slovakia, Philippines, Guatemala, Colombia, Italy, India, Philippines, Nepal. Wow, that's amazing. Malaysia, aerospace engineering, nice. Okay, good. Oh, and we have from Yemen as well. That's very nice to see. Kazakhstan, Angola. Very nice. India, yeah. So that's great. Like I think like the title brought the right people. The title of the talk brought the right people, like the targeted audience from the targeted countries. The next question I want you to answer is like, what do you do? Like, why are you interested in the space sector? Like, are you a student in aerospace? Are you just interested in space, just an enthusiast, or you're working in the space sector? Yeah, also like you can answer in the chat. Okay. We have Marco, who is a space systems engineer from Angola. We have a microbiology student. That's really interesting. A work trainer for the company space professional. That's great, great. So we have people from various backgrounds, people who are just interested in space and people who are studying space, people who are not studying space or not working in space sector, but they're interested in space. We have even professionals here. I see Anmo, who's an international business developer at an Italian satellite company. So yeah, we have quite various number of people from different backgrounds. This is very interesting because this will be a connection point for everyone. I hope at the end of this talk, like we'll get to ask questions and talk to each other like a little bit more. For now, let's dive into the talk. So what I want to do is like by the end of this conversation, I know some of you are familiar with these topics, but I will go like over them. I will make a brief overview over these things. So first we will talk about what is new space, and we'll actually try to figure out what are the characteristics of new space. The second thing will be that we will identify the key players of new space. We will try also to identify like 3 different regiments of new space and what kind of opportunities we can find in each regimen for the suborbital space, the orbital space, and for the deep space. Next, we'll talk about some technology that is shaping the future of new space. It has received a lot of hype, which is the CubeSats. And I would like to talk about it a little bit more because I see more opportunity with CubeSats for the audience that I'm targeting, that you can develop projects using CubeSats, and they're like much cheaper. We will know like how cheap they can get today. And also, like, this talk will serve as an additional motivation for you to advocate for space in your country, in your university, in your family even, and your surroundings. So let's also now go to the chat, and I want you to write, why do you think we go to space? What's the benefit of going to space? Just answer like with a word or two, like, is it just because it's cool, or is it okay? Yeah, I like this answer, Igor. Earth is too small, Igor is saying, because it is there. Clearer view for the future. What do you mean by for the future, Simran? Okay. Wide view of Earth. Resources. Yeah, these are all great ideas. I like that. Colonization of space. No limits in space. Explore new worlds. Monitoring to live in the moon. To find life in other planets like Mars. Okay, that's all great. I like all the answers. So what I would like to add to this, like to add to your answers, is, so when space started, it was about showing off. It was between the Soviet Union and the United States. There was a race where people were just trying to show off their capabilities. There was this was after World War II, where people were like, the two nations were trying to show who is stronger, and so it was for military purposes. So the first applications that I think is good for like the space is to monitor Earth. The picture here represents like surveillance, but you can also monitor Earth for agriculture, for other purposes. We'll talk about this a little bit more. Other reasons why we go to space is to understand space in general, like as a scientific, out of scientific interest, like how did it come to be like as it is now? Why is there life on Earth? Is there life outside of Earth? And on this topic also, we can study the space weather, because we have weather here on Earth, but we also have space weather. And we can study weather through exploration of space. Also, there are a lot of other things. As you said, we can make humans as a multi-planetary species by living in the moon or in Mars. And this is a picture from SpaceX with a vision of with the colonization on Mars, like some visualization of that. Also, other applications which I think we usually kind of don't look at, which is communication. Most of our phones, the TV, the internet today, like, has some link to the satellites. And if you look at at your phone, like most probably, like it will be connected to some satellite if you are using satellite communication. If you are watching TV, it might be that your TV signal is coming from a satellite somewhere out there. Another thing is, as I said, like monitoring Earth for agriculture, for example, like you can see, you can provide some insights for farmers. And so the list of applications goes on, like it's endless. Also, like I have friends like our national points of contact, they are like geologists, And there is also a lot of applications in geology, like if you're studying geology. So next, let's talk about what's new space. I mean, I jumped into new space, assuming that you might know what's old space. But what do you think is new space? Like, what do you think? So if you Google it, like if you Google new space, you will find about 13 million answers. And yeah, I want you to just write down, like, what is your idea about new space? When you hear new space, what do you think? Able to access space at low cost? Yeah. Mars and Moon? Yeah. So yeah, I see non-governmental. That's very good. Smaller applications that can be developed and used in small companies. Space accessible to all. Yeah, I like that. Yeah. Paradigm shift from traditional management to business. So yeah, these are all great ideas, and I think you are giving me some characteristics of the new space, which is really good because basically, to be honest with you, like there isn't one definition for what new space is, but there is a definition that I liked, which is from Airbus. It says that the new space is the recent. The term refers to the recent commercialization of the space sector. While the state used to have a monopoly over the sector, private actors now play an increasing important role. Most notably, companies like SpaceX, Google, Apple, Amazon. These companies are like now entering this. The new are like the new players in new space. So there are some characteristics of new space, which you have mentioned some of them, but I would like to emphasize on them, which is new space is commercial. It focuses on cost reduction, and it makes sure that low cost will pay off. So you're looking for a profit from investing in the space. Before, for example, NASA or like the Soviet Union space program, they were spending money just to either show off or to study things in the space for scientific reasons or for military purposes, but there wasn't any commercial benefit from this. The new space has some commercialization aspect to it, where people benefit, where the companies and governments try to get money out of it. So this is the first aspect. The second thing is it is an innovative, it has some innovative organizational aspects where they try to use some rapid some rapid processes for designing, testing, and developing the technology. So, for example, in the past, some projects would take tens of years, or like a magnitude of like 6, 7, 8, 9 years to develop one project or something. The new space has made it possible through some management and organizational structures, innovations in these areas, had made it possible to make this the technology development faster. The third aspect that I will talk about, which is third characterization, which is mass production. We see that space companies, like the new space companies today, they are like doing this mass production. If you look at Planet Labs, if you look at SpaceX, there is something about producing more and smaller, also with the CubeSats, which we'll talk about soon more. The other aspect is innovative technology. As we have seen in the so in the heart of new space, there is this innovation thing, which is, we have seen it in SpaceX with reusable rockets. We have seen it in Planet Lab with imagery satellites. We have seen it with OneWeb. We have seen it with a lot of other companies which try to innovate and bring new technology to space. Let's have a look at some of the old space and new space. Let's make a small comparison here. So some of the players of the traditional space or old space, as some call it, are like the national space agencies. For example, the European Space Agency, the NASA, Roscosmos, JAXA, um, ISRO, and there are also some private companies that are also considered as part of old space, such as Boeing, Lockheed, United Launch Alliance. But the new companies which we hear a lot about today are the new space companies, which are making the news. Companies such as Virgin Galactic, SpaceX, Blue Origin, Planetary Resources, Deep Space Industries, and so on. So we talked about the characterizations here. I think it's worth mentioning here, like that the new space companies focus on interesting things which can pay money back, such as internet satellites, reusable rockets, imaging satellites, and like recently in the past 2 decades or something, there is the space tourism as well. Some of the things that brought the new space into perspective and brought attention to new space were some treaties, such as the US Commercial Space Launch Competitive Act of 2015, and I think the Obama administration, which allowed commercialization of space. There were also some other acts that were targeted at new space companies to allow for more flexibility and less rigid rules for commercialization that you can see here. So let's talk about space regimens, and I will talk about 3 in particular. I will talk about the suborbital, the orbital, and the deep space. And I will also talk about some opportunities in each one of these. So the suborbital regimen, which is, it's defined as the orbit, the space here, and they're like 100 kilometers or 62 miles. This space here, this is called suborbital. And to give you some perspective into this is where the airplanes fly. They fly at about 16 kilometers or 10 miles. And so this is where the suborbital flight happens. And also to compare this, the shuttle, for example, was flying here at about 300 kilometers or and we have also the International Space Station, or Mir, like before that. So there are a lot of opportunities for new space in this regimen, which is some interesting ones are, for example, microgravity. Some scientific experiments, you want to do them with no gravity. This can be, for example, studying some diseases like Alzheimer, cancer. You need to do some experiments while avoiding the gravitational effect. Also, you can do atmosphere measurement. You can do some technology demonstration, which I think is the most interesting application of this suborbital regimen. I will talk about technology demonstration a little bit later when we talk about CubeSats. But for now, let's have a look at space tourism, which is a sector that brought a lot of hype and interest to people. So let me show you a video here that shows you the experience of going to the suborbital orbit and experiencing microgravity. And it's actually Virgin Galactic calls people who do this, they call them astronauts actually. So they already went to space. It's the suborbital space, but they're considered to be in space. So let's have a look at this. This is from Virgin Galactic. So they have, it starts, their plane starts, okay. So their plane starts with, has two modules. The first one starts like an aircraft, like a regular aircraft. And then once you are in some height here, you launch the second module, which will take you to the suborbital, to the suborbit. And what I want to show you here is like the view from there. So you can see the Earth.
Spaceship Unity, welcome to space. Copy base, $1 million view.
Yeah, and the guy is saying it's $1 million view. So you see this view. So this is why I'm bringing this up. So this is a new sector that appeared, which is space tourism. There are people who are ready to pay money to just have this view of Earth. So if you can, I want you to make a small guess about how much would it cost for you to go to do this experiment, like to go to the suborbita with Virgin Galactic. How much do you think it costs, or it will cost? Write in the chat. Any guesses? $15 million? No, less, much less. Less. We have numbers that are close. Yeah, so Simran, I think Simran got it. Anyways, yeah. So I went to the website and I just went to the Q&A, and it's basically, they are projecting that it will cost around $250,000 to be able to go to the suborbital space, to experience the suborbital flight and microgravity. If I'm not wrong, the microgravity lasts for about 5 minutes. So you will not feel the gravity or your weight for about 5 minutes, from 2 to 5 minutes. Another opportunity for suborbital space is point-to-point travel. So a problem with the commercial air flights is the drag that they face. So you need a lot of fuel, and you need and you cannot go too very high speeds with the passengers on board. So if you go to the suborbit, and then start flying from one point to the other, you can fly in very high speeds. And for example, you can spend a flight from London to Sydney. You can see it will be like below 1 hour, which is amazing, because now such a flight is like at least like 12 or 10 to 12 or like 13 hours or something like that. So this will reduce the travel times. This is still, there are some companies who work on this, but it's still in the concept phase. So the second regimen that I will talk about is the orbital regimen, which includes the low Earth orbit, middle Earth orbit, and high Earth orbit. So the low Earth orbit is between 180 to 300 kilometers. This is where the space station is. This is where a lot of Earth observation satellites are. And then between them, there are like, there is a less number of satellites because of the radiation and some other considerations. But then when you go to the high Earth orbit, you find you find the communication satellite, the geostationary satellite. This is about 35,000 kilometers from Earth. And just to have some magnitude, if you look down here, I don't know if you can look below the screen, but this is the high Earth orbit, which you can see here, and this is where the moon is. Just to give you some magnitude about how things are. So what are the opportunities on this regimen of space? There are a lot of opportunities which include fundamental disease research. Like now, I will talk about the International Space Station a little bit because this is very relevant to get an idea of what we can do there as a new space, what new space can do there. So some of the things that are done there now are like fundamental research, disease research. For example, for Alzheimer's disease or Parkinson's cancer, the heart disease. They're developing also, you can develop in this regimen, you can do research on habitat, like how to make a habitat, for example, the 3D printing in microgravity, how to grow food in microgravity. So these are some applications that are now done in the International Space Station, but the International Space Station can do just, it cannot do all the experiments for the whole Earth. So we still need the new space companies to launch their private stations to the orbit and to provide commercial services, because there is a large market for this. So this is, you can think of opportunities such as building a station like on orbit, which will be commercial, or like private stations. As we said before, there are other applications such as communication, imagery, as you can see here. So instead of having an airplane to fly and image Earth, you can do this using the satellites, which is, if you have like really good satellites, you can have good high resolution as well. And this can be very beneficial for insights about where, for example, the gas is, where oil and gas is, where natural resources are, like minerals, like global climate change. You can also have insights of real-time monitoring for surveillance, for military, for other purposes as well. So we have a question: how would these suborbital flights impact the climate system? Is there a way to compensate the emissions? Yeah, so yeah, one of the concerns is the climate effect of these suborbital flights. I think it's holding back the development, but hopefully there will be some new discoveries or new ideas of how to do this while not harming the environment and the climate as well. Because as you know, like our climate is so fragile, and if we just start messing up with higher layers of atmosphere, we can get a lot of problems as well. Yeah, so yeah, there is actually Karen is saying like that they're working on a sustainable rocket fuel. I would really like to learn more about this. Yeah, feel free to share if you have a link for your website or like your research activity here in the chat. Yeah, thank you, Karen, and thank you everyone for the questions. Also, you can do some space tourism in this orbit, because the suborbital flight, you go and then you have to come back. You don't have the speed to stay on orbit. What we saw before, the one that costs like 250,000, you will just go to space, stay there like for a few minutes, and then go back down. If you can stay in the orbit, which is this regimen, which is the orbital regimen, you can, for example, build a hotel there, and people will start coming. I can assure you that people will pay a lot of money to get there and see the view for on Earth from there. So the last region that I want to talk about is deep space. So deep space is anything beyond what we talked about. It's the moon, Mars. It's also the solar system and all the planetary stuff beyond it. And there are a lot of opportunities there. There are a lot of things that we can think of now, but they're still like in the long term. I can give you some examples, which are space mining, insight resources, which basically in space mining, you are trying to find minerals and propellant for rockets in space. So if you go to an asteroid or a different planet and you can find there some minerals like iron, anything else like water, you can start a sustainable life. So this is really crucial for making humans a multi-planetary species. If you want to go to Mars, we have to find some resources because you cannot bring everything from Earth. So this is one thing, space mining. The other thing is, the other opportunity is colonizing space, which is building habitats in other planets, like for example, in the moon or in Mars. And this topic alone brings a lot of, it just opens the Pandora box, because you need technologies to make the habitat. You need, for example, building materials, 3D printing technology. You need technology for growing plants, growing food in space. You need technology for transportation, for communication, you need all these things. So if we want to go to space and live there, we still need to figure out all these things before we go there. Yeah, so the list is just like endless, so I will just move. So what is limiting us? If there is a lot, all this kind of opportunities of going to space and all these benefits, what is limiting us? So I think there are a lot of bottleneck points, but I will talk only about this one, because about the launch limitation, because of when you want to launch 1 kilogram to space, you need like a huge amount of propellant to launch it into the orbit. If you want to launch it beyond the orbit, you will need even like more propellant, and this adds to the cost. So if you look here at the cost of launching 1 kilogram throughout history, it has decreased significantly, but it's still high. And there is also a limit to how big you can make your rocket, because there is a dilemma. Like if you want to send more weight, you will need more fuel to send it. And if you want to send more fuel, the fuel is also a weight. So you need to add more weight on the fuel to send this fuel as well. So it's like a dilemma, but there is also a limitation to this. So I think this is the bottleneck. So if we start finding resources in space, for example, finding propellant on space, we'll be able to start sustainable life outside of our planet. So just to give you some magnitude of how much does it cost to build a mission, there are some very expensive missions. But it doesn't mean that the mission itself or the technology development itself is expensive. Sometimes the costs of the very high costs are associated with bad management, with some mistakes, with some errors, with overschedule and other things. So if we look at the Curiosity mission that was done by NASA, the cost was approximated to be 2.5 billions, which is really high, and it took about 7 to 10 years to develop this mission. Other missions also cost more, it cost a lot of money, but we see now that the trend is like the missions are taking less time and they're costing less money. These are just a few examples, but what I want to point out here is the cost of CubeSats. So CubeSats is like the new technology here that I will talk about for the next few slides. And they're very cheap. The cost can start from 10,000. Don't let this number fool you, but this is the very minimum for a very basic module of CubeSats. And the development time is much shorter. If we look at mass production, for example, what Planet Labs do, their satellites cost between 10 to 60,000, and their development span for the satellite is like less than a year because they do mass production. And this is also one of the characteristics of New Space. Animal, do you want to ask a question? Thank you, Karen, for sharing your information here. Thank you. Animal, do you still have a question? Are you raising your hand? Okay, so let's move on. So, so the first CubeSat concept was developed by a professor in California Polytechnic State University and Stanford University to provide students with experiments. So their idea was, we'll make a small satellite, so that students will understand how satellites work, what kind of components go into satellites, and after some time, they started standardizing and adding standards to these CubeSats, and it became a standard thing. So what you see here is a 1 unit CubeSat, which is basically 10 centimeters by 10 centimeters by 10 centimeters, and the weight is usually with the standard is like less than 1.3 kilograms. So to give you some how it might look, so you see this plan. A CubeSat would be the size of this pot here, just like a cube thing. So now that you have an idea of what a CubeSat is, let's have a look at what kind of missions can the CubeSat do. So because the CubeSat is small, you might think it cannot do everything. So it can do only a few things. So let's have a look at what it can do. So some of the applications that have have been utilized for CubeSat missions include technology demonstration, where you try to, for example, because space is the space environment is harsh, and if you want to send something to space, you have to test it before you send it there. CubeSats, if you have, for example, a small module like some electronic part or something, instead of just praying that it will work, you can put it in a CubeSat, send it to space, test it that it works, and then after testing it, you can integrate it within your bigger satellite. So this is one type of missions. The other type of missions, which are scientific missions, which you can, which basically you can carry small science instruments to conduct an experiment or take measurements from space. For example, you could collect information on the magnetic field. You can predict the fluctuations. Also, as another example, which is you can do some biological experiments on orbit using CubeSat. You can just send a plate or a small experiment and do it on orbit. The other thing that I think is more relevant to us as students, is the educational projects. Because when you do a CubeSat project, you get to learn how it can provide you with hands-on experience in developing space missions. This can, from the very first steps of designing the mission to launching and operation and everything. So these are opportunities for, I think, universities especially. So if you know somebody who is in your university and you're interested in this, you can, for example, ask them, what do you think about this idea? You can come up with a small idea and ask them to provide you with support or with resources. There are also a lot of other resources online for example, like free launching or like cheap launching, I can say. And then there are also some commercial aspects. So it's not only about demonstration and stuff. There are some companies that use CubeSats to bring money to themselves. So some examples of this is like providing telecommunication and providing imagery. So I will give you one example about. So before I give you the example, I wanted to show you this diagram, which shows the number of CubeSats launched by year. So before, there were very few CubeSats launched, very few nano-satellite launches in the past. And with time, it's increasing. So, and it's predicted to reach about like just below 600 nano-satellites by 2023. This is because, I mean, among other reasons, that there are some companies that are launching in large quantities of CubeSats, of nano-satellites, but it is still showing a trend here, which is they're becoming more popular. I wanted to show you how a CubeSat is launched.
Сегодня Международная космическая станция – это не только уникальная научная лаборатория с массой возможностей.
Спутника, японским
So this is an
манипулятором.
example
Ждем.
of a CubeSat that's being launched from the space station, from the International Space Station.
В открытый космос микронного мощной пружиной.
So you see the small CubeSat? So this is a 3 unit. So what I showed you here was 1 unit. That one is a little bit larger. So if you stack 3 of this together, you can get something like this. I think this is even 4 unit.
Прекрасно.
В разнообразных целях. Для связи.
Yeah. So I think one of the questions that they promised they would answer is like, how much does a satellite cost to build? I think it was, it's really hard to answer this question, but I will give you like an answer about CubeSats, like how much it costs to make a CubeSat. So it all depends like on what kind of mission you will do, if you have free launching or not, because usually the launch will cost you like a lot of money to orbit. So if you are a fan of satellites and things, you can just go on Google, for example, CubeSat kits. One of the providers, which is Pumpkin CubeSat kit, they provide the small CubeSat kits, which you can build by yourself. And they can cost you up to like $9,000. But I think you can do better than that because you can make things by yourself. This is a small kit, like if you're lazy, you want just to buy a satellite and just launch it into space, you can do this. But if you want to do things by yourself, you can build things from scratch. And there are also guidelines that you have to follow, and you can, and if you find free launch, you can your cost will be actually below $10,000. So if we go with this option, which is the base kit, you can, for example, get $9,000 for the CubeSat, and then you will spend another $40,000 or $50,000 for launching. This is expensive, but it's still like better than the millions of dollars that we saw with other missions by old space. So I wanted to share a success story here of Planet Labs. We don't have a lot of time, so I'll go directly to show you what Planet Labs do.
Global change is accelerating, and the world is increasingly interconnected. And satellite imagery has been critical for capturing that change. But the traditional model of satellite imaging isn't keeping pace with the demands of our shifting world. You need to capture change as it happens, to make mission-critical decisions in ever-changing contexts. Planet operates the largest commercial constellation of very high-resolution satellites, capturing imagery multiple times a day, providing unprecedented visibility and intelligence. With Planet, you can collect time-sensitive information right when you need it. And with our improved 50-centimeter spatial resolution...
So you can see here the resolution is very high. Also, they're using CubeSats, like a 3-unit CubeSat. They were able to achieve a very high resolution. And basically, because they are launching a lot of satellites, they can cover a large area of the Earth, and they can take pictures basically every day. So you can see what changes in the environment. If you are like, if this can be helpful for agriculture, for the government, for many reasons.
You can see even finer details than before. With Planet's rapid revisit capability, you can monitor assets in remote parts of the world, up to 12 times per day.
This is amazing, like 12 times per day, like it's...
Predict activity, understand events as they're unfolding on the ground, stay ahead of disasters, monitor infrastructure, and track assets. With Planet's new tasking dashboard, you can task what you want, when you want. Request imagery fast and on the fly. Track and modify progress on your own terms. Download the data and make informed decisions. Now, with 6 more SkySats launching soon, you'll be able to capture more, faster, and take decisive action. A world of possibilities awaits you. Act now with Planet, and be ready for the change the world brings.
So as you saw, there are a lot of applications for this kind of imagery, and you can see here their CubeSat. It's tiny. It doesn't cost them a lot of money. Like with their mass production, they produce it with at very low cost, because they have in-house technology where they build the satellites by themselves, they operate them by themselves, so they reduce the cost significantly. So this was a success story that I wanted to share. Because we are running out of time, I'll just go over this quickly. This is a map that shows the countries which have launch capabilities, countries which have which don't have, countries which are planning to. What I wanted to say here is, like, we see that a lot of countries are understanding the importance of space, and they're trying to become more active in the space sector. The other thing I wanted to show is these are some of the emerging space nations. They contribute to the space activities either through buying satellites, through launching satellites, through making satellites by themselves. And this is basically covering a large part of the world, a lot of countries in Africa, South America, and the Middle East, North Africa, and then Asia as well. And yeah, so the takeaway from this is new space has opened opportunities for everyone, and we have to utilize it. Doesn't matter how. Like, if you're a student, you can study about these things. If you're not a student in the aerospace field, you can still advocate for space in your country. If your country is not active in space, you can talk about it in platforms like the one that I'm using now, for example, like Space Generation Advisory Council. And you can also make your friends more aware about opportunities in this sector. So with this, I would like to thank the Space Generation Advisory Council for hosting me. Specifically, I would like to thank the Space Generation Advisory Council of Yemen, the National Points of Contact, Mohammed and Hamdi, who were very helpful. I want to ask you all to kindly fill the survey that I will send now in the chat. If you can fill the survey, I will keep this screen for a few moments if you want to scan it with your phone. But I will receive questions now. If you have any questions, you can ask them either in the chat or unmute yourself and talk. You don't have to ask a question. You can just give a comment if you want, or just say hi if you want. Yeah, you can unmute yourself if you want to.
Hello, my name is Jorge Aponte. I want to ask you about your presentation.
Yes.
What could be the opportunity for new countries like Colombia or other in Latin America if that service of CubeSat is already put in place?
Yeah. So CubeSats is just the standard. Space is really large. It's like a very large sector, and there are a lot of things that you can do for your country. For example, if you can think about making educational projects, for example, in universities, because you will be able to give hands-on experiences for students. If you have educational programs in universities and students are studying space programs in Colombia, this will be the first step, for example, to open a space agency. And if you have a space agency, you will have access to space. Like today, for example, in the very short term, you can have, for example, communication satellites. You can have monitoring satellites, for example, for the agriculture. You can monitor, for example, for surveillance, see where there are some suspicious activities, for example, in some areas. You can have insights into other things. But in the long term, for example, if in the future we start, humans become like a multiplanetary species, and we, for example, move to Mars or move to the moon or find some resources in space, if there is a country that's very far behind, I think they will be very disadvantaged, because the countries that are now exploring space, there are some treaties that protect everyone, but still, if you are in the first seat and you're exploring space, paying a lot of money for this, and you discover some resources, or you discover, or you move to a new planet, you will have small advantage. So in the long term, also there is benefits. There are some benefits. So. Yeah, thank you, Victor. So Sondes is asking what would take, for example, to start a space agency in a specific country. It's really, it's not very straightforward. There isn't a single answer to this, but I think the first thing you need to do is to get the attention of your officials, like the government, and the people. If people don't care about space, if they think that it's not really useful, it's just like for not for us, for the rich countries, for the developed world, then the government will never look into making a space program or a space agency or investing in space. But if they see, for example, that there are a lot of benefits from this, which is true, like there are a lot of benefits, but some governments have a lot of other problems. Like, for example, in my country, like we have a lot of other problems going on that they wouldn't look into opening a space program. But I believe that you still can do a lot of things in parallel, like to advocate for space, to make to put your fingerprint so that people will start looking at space and start becoming more aware about the importance of space. Yeah, so I would remind you again to fill this form. This will help me understand like of what can we do in the future and for our in our program and for the future talks. Thank you all for coming today and for tuning in and for staying until the end. I also would encourage you all to share your LinkedIn accounts here if you want, if you wish. If you want to go, you can go now. I will just leave it open for a few more minutes. If there is somebody who wants to share anything, if you can share your LinkedIn. I just shared my LinkedIn. If you want to say any final words, I will leave it open for a few minutes.
Simran, tell me a little bit about fishery, about illegal fishery, please.
I'm not sure I got your question. Can you repeat that again, please?
I'm talking about fishing and illegal fishery.
Illegal fishing in the ocean.
Yes.
Yeah, I mean, it might seem that this is a remote topic, but it's not actually, because you can monitor Earth and see where there is some suspicious activities, for example, for boats that are for example, doing some illegal activities that are not registered or something. You saw how Planet Labs, for example, can take images with a precision of a half a meter. This can tell you, like, if you see like a ship that is doing illegal activity somewhere in the ocean, you can inform the official the government or people who are responsible for this, and they can take action actually. Yeah, I think this is really great. Like, everyone is still here. Like, I don't know if I see a lot of people shared their LinkedIn, and this will be a good opportunity for me to share mine as well again. Please feel free to connect. If you have any questions, also you can text me there. Thank you all for the very nice talk and very nice morning, and hope to see you in the future talks. Thank you.
Okay, thank you, Suhail.
Okay.
So we are lucky that you promised us you will give a series of lectures in future.
Yeah, hopefully, like, we'll get feedback. We'll wait for the feedback and see how we can organize this.
Okay, fine, that's it. So in the end of this webinar, I would like to, on behalf of me and Space Generation Advisory Council team in Yemen, and also on behalf of the audience, I would like to thank you very much for your very wonderful lecture, and hope to see you in the future soon.
Thank you. Thank you very much.
Thanks for all the attendees who are attend our the second webinar, and soon we will announce the future webinars. We are having a series of webinars in the future.
Yeah, yeah.
So thank you to all. Thanks again, Suhail.
Bye-bye then.
Thank you. Thank you.